Colleagues, we have one last use case to address, which is use case 2, training detection model to recognize seed types. So let's straight jump into it. Here is 3 projects which will be necessary for us to walk through this use case. Let me explain it. So suppose that we have production images, and for these production images we would like to build a detection model that can recognize, or more precisely detect, different types of seeds. For example, pumpkin unpeeled seeds that looks like this, pumpkin peeled seeds that looks like this. Also we have sunflower seeds, and also we have some mixture of seeds, either all types of seeds or just 2 types of seeds. So suppose that we would like to build a detection model, but here is the challenge. So we have very limited training data. More precisely, we just have 3 images, 2 of which completely irrelevant and 1 is relevant, and the one that is relevant is just partially labeled. So for each type of seeds we actually have several instances, and these irrelevant images with corn also partially labeled, and why we need those I will explain in several minutes. But here is the question: so if we have so little label data, so small amount of label data, is it possible for us to build a detection model that might provide us with some meaningful results? And the answer is yes, and I will show you how. The basic idea is that we will use these instances of labeled objects and paste them. We copy from this image and paste them into random backgrounds. So, and we do have some random backgrounds which are just unlabeled images like this. So those images don't have to be tables. They might be just different, say, images with nature or something. And those images are completely unlabeled. So let me show you how we can act in this low data, in this regime when we have very limited amount of label data. So we can generate data artificially, and to do that we may just run one of the apps from ecosystem. Let me show you which. So for example, flying objects. I run it on top of this project, on top of foreground object, foregrounds project. So let me run this one. There is some process here. Yeah, the app is started. Let me open that. So we provide some information already about foregrounds. So foregrounds is when we have something labeled. Let me also provide information about background. So we will say that, okay, here is a project with our backgrounds. Then I have to specify the classes, and as we have seen, we have just 7 objects for peeled pumpkin seeds, 7 objects for sunflower seeds, and 5 objects for unpeeled seeds. And also corn. That will be used for noise to make the images more complex at the training time. So you will see it in a second. I will just pick that one. I will just pick all the objects. Then I have to specify how I want to compose my images using this artificial data generation approach. And in this case, what I would like to achieve is to actually put on an image a lot of objects so that each image is really complex. And I would also require that each time I put an object, half of this object is at least half of this object is visible. I may specify more parameters, but probably I will not do it so far. And lastly, post-processing, which defines what output, how I would like to label the output data. So, for example, I may say that, okay, let's generate data for detection task. Since we compose, or rather this app compose the images itself, it knows how to label. So that's one example. You see, it's kind of a big mess of objects here with this core object as a noise. Let me just show you another example here. Yeah, so this is another example of artificial generated image. And it's important to say that we may generate data for different tasks, for example, for instance segmentation. So again, the app constructs the image itself, so it knows where the positions and pixels of the specific objects. And that's very convenient, actually. So again, let me go back to the detection case here. Let me see one more image here. Okay, so the next step, what I would like to do next is to say something like that. I would like to generate, say, 200 images of this type, and put them into some project. So say I will just call this project, say, training set, say, might be any name. Okay, and I think that I have done everything here correctly, and what I need to do is just to click generate button, and this app will go and generate images one by one. So it now generating a second image, and once the images are generated, we will have a new project with this name, with one data set that will contain 200 generated images. So let me probably pause here and come back when all the images are generated. I am back, and the app has generated training set, this project called training set, and put there 200 artificially generated images. I should probably close this app now, but let me actually say that if we want to generate more, say with maybe different parameters, more data with different parameters, we can essentially modify some settings here and just define the name of different name for the data set, and keep generating more and more data. I will not do it right now. I think that 200 images that we have artificially created will be sufficient for our task, but let's see. So let's go to projects. So here is this project that was automatically created, and let's open that and quickly take a look at the data that we have. So you see, we have quite a big mess of these seeds and corn. Let's open one of those. So the main idea behind this approach is that it might be a good idea to make the life of the model really complicated during training time, and hope that production images are actually easier than this. So that's the idea, and maybe we can get away with the fact that these images are not looking that realistic. Maybe realistically looking images are not that important, for example, in this case, or in general. Okay, so we have the images like this now. So we went from no data, almost no label data at all, to the state when we have 200 images with a lot of objects. Okay, the next step is to just take some detection model and use this data set to train the model. Let's take YOLO. So I will go to neural network menu here, and I will just run this train YOLO v5 app, and I will use RTX machine as a backend. So let me run this app. So after a while the app will be ready. Started. I can open the app. So what we see here? We see that we have a large number of objects now and 200 images. So let me so in the training I will need all the objects. Also, I may have a choice how to split the data, and in this example I will just split the data. So I will just put some number of images into validation set and the rest of the images in training set. So let me actually do something like that. So 20 images, not that much, but I think it will do. Okay, so I have defined how the data, how I want to split the data. Now let me take a backbone. So it's quite, so our training set is quite complex. So let's speak powerful backbone, powerful model. Also, let me put 200 epochs here. We will have to wait like about 40 minutes, I don't know, before the model will be trained. I will pause the video there. Okay, there are other parameters here that we might control. For example, batch size. The one parameter that is important is optimizer. So I will pick Adam, and I will also follow the recommendation that says here that I should increase learning rate. So you see that some of the parameters are here in the interface, the other parameter is defined as in text format, and those are advanced parameters that original repository allows to control. I will also disable mosaic augmentation here, since we have a lot of objects on the image. I think more or less I have defined everything I wanted here. So the only thing for me left to do is to click this start training button. So, and what is going on right now is the data and annotations. So this 400 means 200 images plus annotations for each images are copied to the target machine, and the training procedure will be conducted on this target machine, and we will see some metrics in real-time regime while the training is happening. What I actually thinking to do probably is to stop here and come back when the training process is completed and we have all the charts that we could analyze. And after that we will just take the best checkpoint according to validation and run it on real images, and to see if the approach to leverage artificially generated data will work in our case. So let me come back. So it just will take some time or maybe I can just wait a bit until the training is started to show you that there are actually some live things going on, and numbers and charts are updating and so on. Maybe I will wait a bit. Yeah, so you see, those are the charts, like some metrics and precision recall and MIP, and as training go on, we will see some dynamics here. Those are just visualizations that was originally represented in the YOLO v5 repository, so it was relatively easy for us to just put these files in the app. In our case, we have a lot of objects, so those might be not that representative for our case, but sometimes those kind of visualizations are useful. And as well as these visualizations of images that we use for training. And we see that the training process has begun. And let me actually come back when we will go through these 200 epochs. And right now we're at we have done just 2 epochs. Okay, see you later. Okay, training process is completed and I'm back. So let's see what we have got. I will skip all the visualizations here. Probably I will say a few words about the charts So we see that errors goes down as the training proceeds. And here we see that precision recall chart, and we see that actually precision is close to 1 on the training set and recall is slightly lower. And the reason is that our images are actually just a big pile of all the seeds, so it's hard. We specifically designed this training set in a way that it is really hard for the model to recognize everything correctly, and in general the metrics goes up and then saturate over time. So the result of this app is actually these artifacts. Here is the link to the artifacts that this training app has generated. So let's just click on that and go to weights folder here, and the app outputs, among other things, 2 checkpoints, the last checkpoint and the best checkpoint. Let me actually try to take this best checkpoint, copy paste to that, and then deploy the model based on this checkpoint and see how it will work with the real data. So let's do that. So let's go to neural networks and let's pick a proper serving app. So we trained YOLO v5, so we will use serving app for YOLO v5. I will run this app. I'm not interested in pre-trained models, so I will run custom models that I have trained. So, and also I will pick the machine here, and let me just click run to deploy the model. It will take a while, hopefully not too long. Yeah, so the model weights are downloaded and the model is deployed on the selected machine with GPU. And the next step to see how this model trained on artificial data will perform on real data. So let's go to projects. And what we will do, we will try to process these images with the models that we have trained on artificially generated data. So let's go back. And here, what we will do, we will just click on the project and select from neural networks context menu this app. We have used that in this demo already. So let's run this app. Yes, the app is started, so let's open the interface. I will connect to the model. And here I will see that I connect to the right model because this model outputs like 4 classes: corn, peeled seeds, sunflower seeds, and peeled seeds. I might disable actually corn because I know that there are no corn there, but okay. I may also specify some thresholds, so maybe I will just slightly increase the thresholds here. And those are just the preview. And we see that actually most seeds are recognized on this example. But let me actually apply the model to the entire project to obtain new project with the recognition, with the detections, and later analyze that a bit. So we just have here like 52 images, and we're about to process them all. So now we have a new project, and this app is completed. So let's actually go to projects, and this is a new project that was generated a few seconds ago with these recognitions. Let's just quickly examine the results. So, for example, those are unpeeled seeds, and let me do the following. Let me probably decrease a bit the height of these boxes. It will be, the results will be better visible. So here I may say that border size, put border size to 2 instead of 5, and this will allow me to see this result. So we see that results are actually quite good, especially when the number of objects are relatively small here. Maybe here the results might be a bit worse, but no, the results are actually quite good. Yeah, so let's go and see another examples here. So for example, sunflower seeds. Okay, let me pick the image first where there are relatively small number of objects, and we also see that the boxes are quite tight. Probably I may find some missing things here and some mislabels, but it's hard to expect from the model the correct recognition of this small thing that was not in training set. And let's see. And even if the number of the seeds are quite high, we see that the recognition is good. So yeah, we might see this false positive here. False positive example here. They happen from time to time, but the point is that we actually had no data at the very beginning, and this approach that we followed allowed us to obtain a model basically from no label data, and now we could leverage this model to pre-label images, and you see that like the results are quite good. So for example, to make it even more visible, let me probably filter the results based on the class. Say I'm interested in specific class, unpeeled seeds. So for example, I see here that it got everything except this corner cases probably. So yeah, I think that the last data set here to examine is this mixture of seeds. So let me open something. Yeah. So we see that the results are actually quite good. So probably I could show you one more thing. So once we have the model deployed, I actually have a way. Maybe I will just yeah, so probably I will not show tags here because there are too many objects. Okay, so another way to leverage the model deployed is, for example, to use it right inside this labeling interface. So let me show you that. So what I will do, so I can run apps right from labeling interface, and I will run this and an image labeling app. And this app is actually allows me to apply models on the fly to the images. So for example, I connect to the model like this, and maybe I'm interested in just one class, say. Maybe I'm just interested in say sunflower seeds. So I will disable all of that, and I will just drop the predictions. So drop all the objects, and maybe I will also increase confidence slightly, so something like that, and this threshold for NMS, and what I can do, I can actually apply this model to the image right inside labeling interface. So if I click here, I will get this sunflower seeds processed in this kind of fashion. There are actually more things that this app allows to do. I can actually undo if I want. So let me probably show you the last thing here. So maybe I will create just another class called area, for example, and I will define this kind of area. And what I can do, I can try to apply the model the model inside the area. It might be useful if I have a high resolutional image and I just interested in some specific area of the image. Let me try to do that actually. So I will try to find sunflower seeds here in this area. So let me try. Yeah, so you see that sunflower seeds are identified within this area and like in this kind of fashion. And I may also undo this. Another use case for that might be if we want to understand model sensitivity to the size of the object. So for example, here the sunflower seeds are really big and I don't expect the model actually to find them, or at least a good quality here, so quality might actually suffer. Let's see if the model, no, it's actually, the sizes are actually not the problem. Actually every sunflower seed was found. That's actually very good for model. Okay, let me try one more experiment. Let me make it fail. So maybe I will just do this and maybe it will fail. Yeah, so you see, it's like some of the sunflower seeds are skipped here, and that's because in the training set we didn't have like this huge sunflower seed that occupies half of the image. Okay, so probably I should stop here because I could show you so many things more. Maybe I will just summarize and what I specifically like about this example is the following fact. So initially we had just these images to process and our training data was very limited, and even though we have very limited data, we were able to obtain a model that does a good job, and we could use this model to pre-label or for some other purposes. And this example illustrates nicely how we can go from raw data to the model in Supervisely. So I think that's it, and see you in the next section. Bye.